Hi all, welcome to my YouTube channel Know About Embedded System. In this video, I'll be explaining about one important topic in embedded system that's called as pipelining. Without pipelining, my processor will take 1000 milliseconds to execute 1000 instruction, but with pipelining, it's taking 333 milliseconds. So which one will we prefer? Being an embedded engineer, time is very crucial in our embedded system. How much less time you will take, that much efficiency will be there and that much faster your processor will execute. So that is the main motto. The execution speed or instruction executions we are going to perform parallelly. Not all, at least 3 instructions. So instead of going single instruction execution at a time, we are going to execute 3 instructions parallelly so that my execution speed will be more and my system will be more efficient. What definition the pipeline says? The pipeline says like this: pipeline is a process of arrangement of hardware in the CPU to increase the speed of execution and to improve the system performance. So this is what I told you. In order to increase the speed and in order to increase the performance of the system. So how it is done, that is the CPU will take care. The parallel execution, it is already programmed in the processor itself. Okay. And also, so this is why we require pipelining. So this first point what we are seeing, it is a definition why part, why pipelining is required and what pipelining says. The pipelining says definition like this: simultaneous execution or a parallel execution of fetch, decode and execution in a one instruction cycle is called as pipelining. Pipelining is a process of a parallel execution of fetch, decode and execution is called as pipelining. I hope this is clear to all, right? Yes. Now let us move to one understanding. Yeah. So if you consider any instruction, as I told you already, I'll consider simple one instruction such as move or not, comma 1 2 3 4. So in this instruction, this is a very simple instruction. This simple instruction, as I already told, so there will be 3 parts. The single instruction will have 3 parts. Let it be any simple it is. So we will have fetch and decode and then execution. If you consider any simple instruction, we will have three parts in that: fetch, decode and execution. So what is this fetch, decode and execution? That I'll explain you a little later after 5 minutes. Just as of now, you can keep in mind each instruction will have three subparts: fetch, decode and execution or execute. So whenever you're executing this instruction in parallelly, then that process is called as pipelining. Now you can see here, so this is my instruction numbers, instruction number 1 2 3 4, and this is called as your clock cycles. Okay, the clock cycles and instruction cycle here. So in the third instruction, you can see, so I have given the numberings here: instruction fetch 1 in the first cycle, instruction decode 1 second cycle, and execution 1 in third cycle. So if you observe very clearly here, in the third cycle, execution of first instruction, decoding of second instruction, and fetching of third instruction. This process is called as pipelining. In the third cycle, I am performing 3 different operations. One is execution of first instruction, decoding of second one, and fetching of third one. Since I'm performing 3 executions in a single cycle, that process is called as pipelining. So this is called as pipelining. Parallel execution of 3 different tasks is called as pipelining, and very specifically at this point, this is called as 3-stage pipeline. There are different types of pipelinings are there. So this is called as 3-stage pipelining. And similar to this, we have one more use case here. Try to understand here. At this point, we have in the 5th cycle, two more cycles are added here. You can observe very clearly, along with the fetch 5, decode 4, execute 3, memory 2, WB1. So what is additional two cycles, memory and WB, that I'll explain in the theory part after this. But at this stage, 5 instructions are executing parallelly. Instruction 5, fetch 5, again, decode 4, execute 3, memory 2, write back 1. At this stage, this is called as 5-stage pipelining. At this stage, it is called 5-stage pipelining. So very popular, the pipelining are 3-stage and 5-stage. So I hope you have understood what is the definition of 3-stage pipelining and 5-stage pipelining. Each instruction will have at least 3 parts: fetch, decode, and execute. Some instruction may have even 5-stage operation as well. So whenever your processor is executing 5 different executions in a single cycle, then that is called as 5-stage. And whenever your processor is executing 3 different tasks simultaneously, then that is called as 3-stage pipelining. I hope this is clear to all what is pipelining. Right? So with this, let us go back to the theory part, what theory says. Yeah. So now you can see here the definition of each stage. As I told you already, every instruction, at least it will have 3 stages. As I told already in the explanation, at least if you consider any processor will have at least 3 stages. That is fetch, decode, and execute. Some operations, some processors go for even 5 stage as well. That is called as memory and WB. WB stands for write back. So what is the definition of fetch, decode, and execution? Let us see now. What do you mean by instruction fetch? Instruction IF, in short form we will call IF. So the full form is instruction fetch. So what do you mean by this? The fetching an instruction from the memory in the form of hex code. So whenever you're going to execute any instruction, the instruction will be saved in the form of hex code in the memory. Before executing any instruction, we have to fetch it from the memory. That process is called as instruction fetch. Okay, that is the definition of instruction fetch. The second one is instruction decode. Instruction decode means decoding the hex code and converting that hex code to binary code is called as decode operation. So we have the processor will decode it to understand its functionality. So whenever you fetch the instruction, first that will be converted into binary and later it's going to decode its meaning. That process is called as instruction decode. And the last one is execution phase. Execution phase is nothing but the final execution. After understanding its meaning, the processor will execute the binary code. That's called as execution phase. So these 3 are mandatory attributes or mandatory tasks of a pipelining, at least 3-stage pipelining. After that, the 4th one is memory access. Okay, now what do you mean by memory access? Memory access means, in short form, we will call mem. Mem stands for memory access here. What it says, after execution of your instruction, the results we have to store back to the memory. At this stage, memory operands are read and written to the memory. That means after performing action, results will be stored back to the memory. So in the 4th stage, results will be stored back to the memory or data will be retrieved from the memory as well. That particular operation is called as memory operation, right? The last one is called as write back. Write back means in this stage, computed value after executing the instruction, processor will write back to the register. Data will be returned back to the register which are present in the instruction. This process is called as write back. Okay, so I hope this is clear to all. Pipelining, at least 3 stages will be there. One is instruction fetch, decode, execution, memory, and write back. Okay, so what is the pipelining? Again, I'll go back to the first definition here. The pipelining is a simultaneous execution of fetch, decode, and execution in a single cycle is called as parallel execution, or it's also called as pipelining. So what is the advantage of pipelining? The pipelining process will increase the speed of execution, and also it will improve the performance of the system. So this is the advantage of pipelining. Please subscribe my channel, and we will meet you in the next video. I'll come up with the next video. Till then, keep watching our channel, Know About Embedded System. Thank you. See you in the next video.